let's see this equation. If we want to solve for x in normal way, there'll be a lot of trouble. So we're going to use trigonometry to solve this equation. Because we see this square root of x squared minus 1, that reminds us a Pythagorean theorem. Right? If we make a right triangle, just pretend this is a right triangle. Right? X squared minus 1, we can think this is x, hypotenuse is x, then maybe this is 1. Then this side would be square root of x squared minus 1. If we call this angle alpha or theta, call theta. Then we see x, let's write down, let's see, sine theta equals the opposite, which is 1 over hypotenuse, which is x. And then 1 over sine will be x over 1, which is x. Right? So that means this term we can write as 1 over sine theta. And similarly, we have this cosine theta is adjacent, so square root of x squared minus 1 over hypotenuse x. And if we flip the numerator and denominator, we have 1 over cosine equals x over square root of x squared minus 1. Right? So that means this term can be written as 1 over cosine theta. Then that equals 2 radical 2. Now let's simplify this. Simply, so we multiply sine theta, cosine theta on both sides. So we multiply basically everyone with a sine theta and cosine theta. So multiply by the first one, we get a cosine theta, because sine over sine becomes 1. The second one, we have sine theta, because cosine over cosine becomes 1. Then equals to 2 times radical 2 sine theta cosine theta. Now, if we remember double angle formula, right, 2 sine theta cosine theta, that equals to, we still have radical 2 here, times the sine of 2 theta, double angle formula, right? Sine of 2 theta equals to 2 times sine theta cosine theta. So that equals to cosine theta plus sine theta. Now let's divide everything by square root 2. Right. Then we have, let me move a little bit. Then we have, so cosine theta divided by square root 2 plus sine theta divided by square root 2 equals to sine of 2 theta. Well, remember 1 over square root 2 or square root 2 over 2. That's the value of sine 45, which is pi over 4. And cosine 45 or cosine pi over 4. Right? So that means this one we can write as some, should we use a cosine? We can use either one, right? But because we know sine of 2 theta also can be written as a sine of theta plus the theta, right? So another way, so let's write this. So that means we have 1, let's write this way, sine 45 times cosine theta plus cosine 45 sine theta. And that equals to sine of 2 theta. You see what this forces this to be? Because sine of 2 theta equals to 2 of sine theta cosine theta. So that forces theta to be 45. Right? If theta is 45, well, what's the x value? X is 1 over sine. So x equals to 1 over some 45, which is 1 over square root 2, which just square root of 2. All right. Right, or you can use this value. Okay, so this is just to want to show one way to solve this kind of equations. When we see square root of a difference of, you know, x squared minus 1, automatically we think about the Pythagorean theorem.